Today we're going to cover the topic of scientific notation. Scientific notation is a form of writing very large or very small numbers so that they're able to be manipulated through addition, subtraction, multiplication, or division, or even compared to each other in a much more easier fashion. We describe numbers in two different ways. Standard form, which means to write a number using all its digits. And what's called scientific notation, which is to write numbers as the product of a power of 10 and a decimal greater than or equal to 1, and less than 10. The way we write that is as follows. A times 10 to the n power. The reason this is so easy to use is 10 to any power is easily transferable into a standard form number by just moving the decimal place a certain number of times based upon the exponent. The key is that A has to be greater than or equal to 1 and less than 10. So let's work through a few examples going from scientific notation to standard form and standard form to scientific notation. So let's take the number 234,567,000. Obviously a very large number. Can I rewrite that number in scientific notation? Yes. The way to do it is the decimal point is located currently here. I need to change this number so that when it's rewritten, it's a number between 1 and 10, including 1. So I'm going to move my decimal to the left until it's at a place where the number will be between 1 and 10, including 1. And I stop between the 2 and 4. So this number is now between 1 and 10. That solves the first part. But it's not equal to that number. I still need to multiply it by a number in base 10. The way I figure out the exponent is I count the number of places I moved. 1, 2, 3, 4, 5, 6, 7, 8. And there's my answer. Okay? Now I want to take a number as follows. As opposed to the first example where I had a large number, I now have a small number. So first thing I want to deal with is moving the decimal place. Now I'm going to be moving it to the right. I stop here because that'll leave me with a number greater than or equal to 1 or less than 10. But now by moving to the right, I made this number bigger. Offset it, my base has to be my exponent has to be such that will make it smaller. Or, and put another way, this is a very large number. I'm expecting a positive exponent. If it's a very small number, I should be expecting a negative exponent. I move 1, 2, 3, 4 places. This is to the negative fourth power. So if you keep in mind positive exponents make numbers large and negative exponents make numbers small, that will help you when figuring out the sign of your exponent. Now let's go in the other direction. Let's say I want to take a number that's already in scientific notation and I want to convert it to standard form. So I have 9.001 times 10 to the negative fifth power. Well, 10 to the negative fifth power is telling me the number is going to be small or get smaller. So to make a number smaller, I'm going to move my decimal to the left. I move it one place, that takes care of 1, but I still have 4 more slots to move it. So I'm going to take up those 4 spaces with 4 zeros. So 1, 2, 3, 4 zeros, and there is my number in standard form. Similarly, if I have the number 2.459 times 10 to the 8th, the exponent of 8 is telling me the number is going to get much larger. So I'm going to move my decimal. So far I've moved 3 spaces out of the 8. That means I need to add on 5 zeros in addition to my 9, 5, 4, and 2. Putting in my commas in the appropriate place, I see that 2.459 times 10 to the 8th is equivalent to 245,900,000 in standard form. Now, the other point in dealing with scientific notation is comparing numbers. We've dealt with comparing numbers in a different number of situations. If I have one unit of weight in pounds and another unit of weight in kilograms, that's not really helpful to me. So I want to convert them to the same basis of comparison. So if I wanted to know which is the larger value, (3.9 times 10 to the 6th or 3,800,000. I have 2 ways I can go. I can convert the number in scientific notation to standard form or the number in standard form to scientific notation. I've usually found it easier to go into scientific notation. That's a little bit of a personal preference. So to convert this, it's 3.8 times 10 to the 6th. Now, since they both have the same base with exponent, I now have to compare the decimal part. Since 3.9 is greater than 3.8, I know that that's the direction that it goes. Okay? I want to just give you a few other examples of common mistakes that are made with scientific notation. 4.0701 plus 10 to the negative fifth. This is not written in scientific notation because it has addition. We need multiplication. It must be multiplication. Okay? 0.325 times 10 to the 6th. This is not scientific notation. Because 0.325 is less than 1. Now, I can convert that to scientific notation by moving the decimal one place over to make it 3.25. And now, instead of 10 to the 6th, it becomes 10 to the 5th. I made this number larger. I need to make this number smaller by one decimal place. And the other example, 18.325 times 10 to the negative 12th. Well, this is not in scientific notation because 18.325 is greater than 10. But again, I can clean that up by moving the decimal one place to the left. Since I made this smaller, I make that exponent larger by one decimal place. So that is a summary of scientific notation. We will then work on adding, subtracting, and multiplying and dividing in the next videos.